Hello everyone, this is Vanessa Greer from Wilson Tool. I want to welcome you guys to this month's webcast, Maximize Your Punching Efficiency. We're so glad all of you can join us today. In all of our webinars, our goal is to bring you expert solutions to common sheet metal manufacturing challenges in a convenient online format. Joe, can you flip it to the next slide? Sorry, thanks guys. All right, for those of you who would like a copy of this webinar, we are recording today's webcast and you'll be able to download it from our website as soon as it becomes available. Also, just an FYI, the attendee list is not displayed to other participants either today or in any recorded material for privacy reasons. If you experience any technical difficulties during the session, you can contact WebEx Technical Support at 1-866-229-3239. Also, be aware that you will be in a listen-only mode throughout the presentation. However, if you have questions for our presenter, please submit them anytime throughout the presentation. Just type into the Q&A box to the right of your screen and hit send. This box is labeled Q&A and has a question mark identifying it. We'll try to answer as many of these questions as possible at the end of the presentation. And make sure you select all panelists in the send to list, otherwise we might not see your question. To submit a question when you're in full screen mode, just hover over the green floating toolbar at the top of your screen and select the question mark icon. I want to make a note that there's another box designated as chat available for you to type in as well, and it has a speech bubble symbol next to it. Please do not send your Q&A in this box though. This is intended to be used for technical issues or any other general questions you may have that are not directly related to the webinar material. Okay, so in addition to myself, I would like to introduce Elizabeth Graham, who will be co-hosting with me today. We will be receiving your questions as they come in and running the polls behind the scenes. We also have our applications engineer, Glenn Sheldis, here to assist with the Q&A. Now I'm pleased to introduce today's presenter, Joe Cox. Joe is a sales engineer here at Wilson Tool and serves as the Punching Division sales trainer.
Hi everyone, thank you Vanessa. As Vanessa said, my name is Joe Cox. I'm a sales rep with Wilson Tool. I've been with the company about 7 years, and I currently serve as the punch press training specialist in our CNC turret division. The purpose of today's webinar is to raise awareness and educate our customers about available tooling technologies to help them maximize the efficiency of their punching machines. Today's webinar is mainly going to focus on maximizing tool life, increasing application efficiency, and eliminating secondary operations. The basic agenda for the presentation today is going to be a brief introduction to Wilson Tool, moving on to maximizing tool life, increasing application efficiency, and eliminating secondary operations. At the end, we are going to have roughly a 10 to 15 minute question and answer session, and Vanessa described how you can submit your questions for that. A little bit about Wilson Tool. Our corporate headquarters is in White Bear Lake, Minnesota. We have 450,000 square foot of manufacturing area and roughly 500 employees. We have 3 divisions within Wilson Tool. We have our CNC punch press division, our CNC press brake division, and then we also manufacture punches and dies for the stamping industry. We're going to start with maximizing tool life today, and the topics we're going to cover are proper grinding practices, surface enhancing coatings, and some of the different innovations in tool steels available in today's tooling. We're going to start with proper grinding practices. Proper grinding practices is one of the most basic functions that you can perform to ensure that you're getting the most life out of your tooling. The number one most important thing when grinding your tooling is to apply coolant to the tool during the whole grinding process. Without applying coolant, heat buildup can result in an actual change in the metallurgy of the tool, and it can drastically affect your tool life. We recommend making very light passes with your grinder, only removing 5/10 to a thou in a pass, otherwise that excessive heat buildup can occur. When that heat buildup occurs, the tool can actually become brittle, or on the opposite end, it can actually become soft, and the tool will wear down much faster. You should never have to remove more than 4 thou to 10 thou of material in any given sharpening. After you've sharpened the tool, we recommend running an Arkansas stone or a light oil stone around the perimeter of the tool. This is to remove the burr. You don't have to get aggressive with it, just run it lightly around the edge of the tool to knock down that burr. If you don't knock down that burr, when you're punching holes, it can mimic deflection or even cause excessive wear on one side of the tool, or it can mimic misalignment. The slide you're looking at now is a basic case study illustrating how fast a tool can break down if you wait for longer increments to sharpen your tooling. These hits are not typical. They're used for illustrative purposes only. If you look above the black bar, it's going to show, if you go out to where it says 80,000 hits, in this scenario, the person sharpening the tool waited until 80,000 hits to sharpen that tool. They had to remove 40 thousandths of material from the punch in order to return it to sharp. If you go down below, it's going to illustrate the benefit of making more frequent sharpenings and removing less material. As you can see below, the first sharpening took place at 40,000 hits. They only removed 10 thousandths of material to return the tool to sharp. Again, at 80,000 hits, they removed another 10 thousandths of material. So now they've removed 20 thousandths of material, whereas on the top scenario, they had to remove 40 thousandths of material to return the tool to sharp. Now going on down the line, you'll see another incremental sharpening at 120,000 hits, and then again at 160,000 hits. The 160,000 hits in the bottom scenario has now removed 40 thousandths of material from the tool, whereas they only got 80,000 hits before they had to remove 40 thousandths of material from the tool in the above scenario. This illustrates the benefit of sharpening your tooling in more frequent increments and removing less material at a time. The tools will last drastically longer. Proper grinding practices and grinder considerations. Some of the different considerations when you're considering a grinder are the type of grinder. Are you going to use a bench or a pedestal grinder, a surface grinder, or a rotary grinder? We do recommend a rotary grinder for sharpening your tools. You need to take into consideration the capabilities of your grinder. Does your grinder have auto feed capabilities, or is it manual feed where the operator of the grinder has to babysit the grind the whole time? Do you have the necessary fixtures in your shop in order to do all the various styles of tooling that you have in-house? And do those fixtures also allow you to do the shear angles on your tool that the tools may possess? Also consider the quality of the grind. How much material is being removed in each pass? Does your grinder use coolant? Is the wheel being properly dressed? Building off the type of grinder, what type of manpower is required to run that grinder? Are you going to dedicate a tool and die maker to sharpening the tooling? Will you have a dedicated employee that is at the grinder all day sharpening tooling? Or can your punch press operator sharpen the tools while the machine's running the sheets? And then finally, you have to consider the cost of outsourcing. How much is it the cost to outsource your tooling? How long does it take to get your tooling back? If you're outsourcing tooling, do you have to buy backup tools to be able to run while the tools are out being sharpened? Is it more cost effective just to actually throw away the tools and replace them instead of sharpening? I've actually seen scenarios where customers were outsourcing their sharpening on the dies, and they were actually paying more to have the die sharpened than it costs just to buy a whole new die. What I'm going to show you now is a video of a rotary grinder. It's just going to illustrate some of our recommendations. I do have to apologize. This was a marketing video that I cut up, so some of the voice won't match up with what's going on. The silent portion of that video was part of that video, so nothing went wrong there. What to take away from this section of the webinar? Again, grind your tools more frequently, remove very little material, 4/1000ths to 10/1000ths per sharpening, make very light passes, 5/10ths to a thou with each pass of your grinder. It's going to make your tools last a lot longer. First poll question, do you currently have a preventative maintenance schedule in place? In the right side of your screen, you can answer yes, no, and we don't want or need to, or 3, no, but we would like to. Take a few seconds to answer that question. Wilson Tool does offer free maintenance training seminars at your convenience. Your sales engineer will actually come in. It takes about 45 minutes to an hour, and again, it's no charge, just a value-added service that we offer to you. Moving along, we're going to talk about maximizing tool life. This is going to cover some of the tooling innovations that have been made for today's challenging applications. Some of the different challenges that fabricators are facing today includes the type of steel that's being punched. We're seeing a lot of high strength and abrasive materials, your high strength low alloys, your common stainless steels, which have been around for a long time. And then a lot more high carbon steels are being used today, your grade 50s and your grade 80s. These challenging materials can even increase the tonnage requirements of your tooling and your punch press. Some of the tooling solutions to battle these challenging applications include surface enhancing coatings. There's premium tool steels available on the market today, including powdered metallurgy. And then we can even change the geometry of some of the punches to better help you to decrease that tonnage requirement on your machine and your tooling. Sorry, I'm having trouble changing the slide there. 2 basic types of wear. First, there is abrasive wear. Abrasive wear is when the work material actually abrades the tool surface. The ways to combat these would be to replace tooling frequently, or you can add carbides and hardness to the tool itself. Or you can do both, surface enhancing coatings, and you can go to a powder metallurgy to increase that tool life. Second, adhesive wear. Adhesive wear is where the work material actually sticks and rips out part of the tooling surface. To battle adhesive wear, you can look at surface enhancing coatings, or you can improve the surface finish of the tool. What I mean by improving the surface finish of the tool, you can actually polish the cutting surface of the tool, or in some instances, a bead blast even makes a difference. If you're experiencing both abrasive and adhesive wear, you can move to a more shock-resistant tool steel and complement it with a surface-enhancing coating. Or you can look at powdered metallurgy, which can actually increase your shock resistance or increase your wear resistance. We're going to talk a little bit about coatings, and I'm going to show you a quick video of a punch actually entering and exiting a sheet. And what I want you to pay attention to in this video is once the punch goes through the sheet, you'll actually see the sheet itself, it'll retract and actually surround the punch. As that punch is stripping out of that sheet, that is actually when most of your wear is occurring. 2/3 of all wear comes from the strip out of the sheet. As I said, two-thirds of all wear comes from the punch stripping out of the sheet. The use of coatings can greatly help reduce that stripping pressure and increase your tool life. Coatings are used in both punching and forming. In punching, they're used to reduce friction between the punch and the sheet, reduce material transfer, you might know it as galling, between the punch and the sheet. Coatings can add hardness to the tool itself. And a common misconception about coatings is that once you sharpen the tool once, the coating is gone and it's no good. Coatings are actually not affected by sharpening. Coating's only relevance is on the side walls of the punch itself. So when you're sharpening the top of the tool, it does not affect the coating on the side walls. Coatings are also used in forming. They're very common on forming inserts and on the cutting edge of the forming tool. They help to reduce friction, wear, and edge buildup. They greatly reduce stripping pressure and tool wear. Coatings are often used on the forming insert in high carbon materials to help reduce that stripping pressure and actually allow it to strip out of the sheet. Some of the coatings Wilson Tool offers today, we've got 4 general use coatings. They're not general use, they are application specific, but 4 basic coatings. We offer wear beater, which is a titanium nitride, your typical gold coating. We offer our Optima coating, a titanium carbonitride. And then we have 2 more specialized coatings called Nitrex and Slip Max. A tin coating, the gold coating, is a good all-around coating. Optima coating is an upgraded coating. It's great in stainless. It has a very low coefficient of friction and it adds significant hardness to the tool itself. Very good for stainless, however, it's not recommended in aluminum. Nitrex and Slip Max I see most often used in forming applications on those forming insert to help reduce that stripping pressure coming out of abrasive materials. Going to talk a little bit about tool stills and give you a basic education on tool stills. With any tool still, there are 2 basic components. For illustrative purposes, as you see in the picture, we're going to refer to a cobblestone road, or you can even think of it in terms of a brick wall. The matrix is the first component of any tool still. In the illustration, your matrix would be the mortar of either the brick wall or the cobblestone road. The matrix is the base structure of the steel that holds the alloys together. The purpose of the matrix, not only to hold the alloys together, but it also establishes your toughness or your shock resistance in the tool still, and then it also sets the baseline for the hardness of your tool. It also helps to establish wear and heat resistance. The second component that couples with the matrix is the carbides. The carbides are what actually provide your wear resistance to abrasion. In the illustration to the left, your cobblestones would be your carbides. Again, carbides are hard. They provide additional wear and hardness to the tool still. However, because they are harder, they can cause a reduction in the toughness or the shock resistance of the tool still. There are 2 basic types of tool stills that you'll hear about out there. There are conventional tool stills, and then there are powdered tool stills, also known as powdered metallurgy. They're classified by how they are manufactured. Conventional tool stills, the manner in which they're manufactured, carbides can tend to clump together. When carbides clump together within the matrix, it creates brittle points within the matrix. Because carbides are a percentage of the matrix and that doesn't change, when the carbides clump together, it also creates voids in the matrix or soft spots. Those actually wear faster, and if you have the brittle spots from the carbides clumping, those are chipping points, so another form of wear. Again, voids in the matrix equal soft spots and promote wear. In your powdered tool still or powdered metallurgy, there's a much more even carbide distribution throughout the tool still. If you look below, you'll see the yellow, which are the carbides, very small and very dotted throughout. That consistency in the base of the matrix creates a much greater wear resistance and a much more even wear pattern. Also, both conventional and powdered tool stills are well complemented by coatings. However, with the additional life you get from a powdered tool still, the coatings are a great complement to get the most bang for your buck. When applied correctly, powdered tool stills typically result in at least twice the number of hits before a sharpening is required. That comes down to the carbide distribution throughout the tool still. Wilson Tool has started implementing powdered tool stills throughout their product lines. Some of the families of tools that we currently use powdered tool stills in include our EXP punch tips, our fully guided DuraBlade insert, the replaceable insert for our duratei, and our Trump 2-for-1 punches. We do use powdered metal in a number of different tooling styles and also in a number of our dies. In a previous slide, we talked a little bit about changing the geometry of the punch itself to reduce punching force. There are a number of different type of shear angles available that can be ground on your punches today. These become very application specific, so I'm going to keep this relatively high level. I do recommend that you contact your sales desk representative to get a recommendation for your particular application. Probably the most common type is your rooftop. That helps reduce punching tonnage required for your application. This chart is available in your punching catalog, so please refer to that if you would like to learn more. I'm going to talk a little bit about maximizing your application efficiency. And what we're going to focus on is tools that allow you to streamline your applications to reduce setup time and cost, reduce your cycle times, and help you maximize your return on investment. The first application efficient tool we're going to talk about is multi-tools. Multi-tools are great in the fact that they allow you to consolidate small tooling into a single station. This increases your machine's tooling capacity. How it does this? You consolidate small tools into a single station. It opens up those other small stations so you can load tools. It reduces the setups and the setup time involved. Because you're freeing up additional stations, you may not have to load and unload tools before moving on to your next job. It also helps you to reduce your machine cycle time. It does this because with the tools consolidated in one station, you no longer lose that time in either the turret rotation or a tool being returned to the rail to grab another tool in order to punch your next hole. The tool itself can just index to the next tool in the setup and you're off and running. I do want to note that multi-tools are not available for all machines, and sometimes they do, and actually often they do require an auto index station. Moving along to the next application efficient tool, I'm going to talk a little bit about cluster tooling. Cluster tools are great in large perforation patterns. They reduce your cycle times by punching multiple holes in a single hit. It's a very cost-effective method if you have a large perforation pattern. And no longer do you have to rely on your machine's hole-to-hole tolerance. Because it's all in the same die, a cluster tool allows you to hold extremely tight center-to-center hole tolerance. Cluster tools are available in a solid style or a replaceable insert style, depending on how many pins you have and to lower your replacement cost. Building on the cluster tooling conversation, what you see in the pictures below is called a progressive cluster tool. Progressive cluster tools are great in the fact that they can actually progressively pierce, form, and blank your part complete in the punching machine using a single tool. After the part has been pierced and then formed, and when it's ready to be blanked, it's blanked and then it's either released via a trap door or it falls out your machine's slug chute. Progressive cluster tooling mimics a progressive stamping die. However, with the lower volumes that we're seeing today, looking at a progressive cluster tool can make you much more competitive in your quoting when you don't have to quote a very expensive hard tool for that progressive application. Next poll question, do you plan to upgrade your punching equipment and or your capabilities in 2015? 1, yes, 2, no, 3, not sure. Take a few seconds to answer this question. The reason we're asking is because some of the next tools we're going to talk about do require a programmable RAM in order to run, so they are tied to your machine's capabilities. However, the tools we're going to go over are a great way to increase your machine's efficiency. The next application efficient tool we're going to talk about are wheel tools and the Wilson Tool rolling family of products. Wheel tools allow you to accomplish high-speed production of large embosses, slits, ribs, or you might know them as beads, and offset bins in a wide range of materials with virtually no burrs or nibble marks. Some of the different rolling tools available include the rolling forge, which is a variation of the rolling offset, the rolling logo tool, the rolling knurl, electrical knockout, a rolling edge fleer, the cutting wheel or the shear, the bead tool or the rib, a rolling offset, and a rolling pincher. Wheel tools are great in the fact that they reduce your time requirements and they can eliminate progressive forming applications, which can be time consuming. Now I'm going to show you a basic video of some of the family of wheel tools. Just gives you a good idea of what's out there and how they work. I do want to point out, as I stated, that the wheel tools require a programmable RAM in your machine. It has to be able to hold that tool down in order to accomplish what it's doing. We'll talk about an alternative method to accomplish some of these forms later in the webinar. So that was a little bit about wheel tools, and just to review, what we were covering there was a number of different tooling options that are going to help you maximize the use of your machine and make it more efficient. A lot of our customers we still find are just simply punching holes with their machines. We're just trying to show you and educate you some of the items out there that will help you to fully maximize the capability of those machines. I'm going to talk a little bit about eliminating secondary operations. We're going to start with deburring. Deburring is a common function that everybody has to perform, and we're going to show you some ways to do it in your punching machine. Then we're going to talk about producing connective forms that are going to allow you to actually join your sheet metal without having to take it to a secondary operation. And we're going to finish with minimizing secondary press brake operations, show you how to do some of the forms in your punching machine so that you don't have to send them to the press brake for that operation. The first step with deburring, obviously, is to identify what is causing the burr. Check your station alignment. Are you using the proper die clearance? Are the condition of your punch and die in good working order? After you've identified the cause of the burr, identify the methods to eliminate the small remaining burr. Some of the common methods to remove a burr from your parts are manually driven. You've got your quick burr hand tools, which the operator actually runs down the edge of the sheet to knock the burr off, and very commonly a handheld belt file, which uses an abrasive to actually knock the burr off. There are deburring tools available that you can run in your punching machine. Like the wheel tools, they do require a programmable RAM. Currently, the deburring tools are offered in a thick turret style and a trump style tool. How these deburring tools work is they use almost like a ball bearing that runs along the top and bottom edge of the sheet, and it actually coins the burr back into the sheet using pressure. On the right, there's a few pictures of a deburred part next to the part that still has a burr. This is blown up, so it's very hard to see with the naked eye after you've deburred your part, but you can definitely feel it when you run your finger along the edge of the sheet. Moving along, our final poll question. Are you currently forming in your punch press? If so, what type of forms are you currently producing? 1, countersinks, 2, louvers, 3, flanges of 90 degrees, 4, other, or 5, I don't form in my punch press. Again, like I said, we found a lot of customers are currently just using their punching machines to punch basic holes, and there are a lot of different options to produce forms in your punching machine. This includes embosses, lancing forms, bridge lances, so on and so forth.
Joe, if you just want to, it'll take a second here for the results to come in, but if you just want to wait on this one, you can share the results here with the group.
Okay.
All right, I'm going to close the poll here. It'll just be about 15 more seconds if you want to quick get your answers in. Looking like right now countersink's winning here, but Joe will share the results with you in just a second.
Countersinks are a pretty common form.
Okay.
Countersinks it is, 41%. Louvers are another very common one. 7% of you are forming bends of 90 degrees. This is still kind of taking off. You're limited there by the feed clearance of your punching machine and the capability of your machine. So, and then obviously there are a lot of other forms that you can perform. Good information. I'm going to talk a little bit about connective forms, how you can join sheet metal without having to send it to a secondary operation. Eliminate the use of weld nuts, PEM studs, rivets, or even welding in some instances. One type of connective form is tapping. There are tools out there that will allow you to do tapping in your machine. Most of the machines do offer some kind of tapping option, whether it be a tooling style to do it, or an integrated tapping module into the machine. What you see illustrated here is the DK tapping tool for thick turret, and then also the Trump tapping module. Going to show you a quick video of the DK tapping tool so you're aware how it works in the machine. Again, tapping is very common in the industry. There are tapping modules or tapping tools available for most machine styles. If tapping is a big part of your part mix, I do suggest contacting your machine manufacturer or your tooling representative to see what options are available to you. Some of the other connective forms that are common, there's a connective thread form. Thread forms are typically used in thinner material. They're a light-duty fastening option that you typically see in the appliance industry. They're used where a threaded hole is required, and they are made specifically to a material and screw specification, meaning material type and thickness and what type of screw you are using. Sometimes they require one tool. In thicker materials, they often require a pre-punch, therefore they require two tools. Again, light-duty fastening option, but very common. It's the Tinnerman-style thread form. Moving along, one of the options to eliminate welding is the ZipTech fastening system. ZipTech is a tooling option that replaces conventional welding and grinding, spot welding, and other fastening methods. And how the ZipTech actually works is it creates a Lanson form that fabricates snaps and allows you to push the sheets together. Those snaps do hold very tightly, and they're very difficult, if not impossible, to pull apart. ZipTech does require two tools, and it is available in most tooling styles. Again, a Lanson form style form that allows you to join two flat pieces of sheet metal. The next type of connecting form that is very common is the hinge tool. There are two basic styles of hinge tool. You have your closed style hinge tool or your open style hinge. At least two tools are required in the closed style. Each knuckle requires a minimum of 3 hits to complete. And it can be completed on the edge of the sheet or in the middle of a sheet. I'm going to show you kind of a neat little illustration of how the tapping tool works, just to give you an idea how it's formed in your punch press. So you saw the first 2 hits formed by one tool and then the final rollover completed by a second tool. There are designs available that will allow you to work with either a mechanical ram or a programmable ram. The next type of hinge tool we're going to talk about, or hinge style, is the open style. The knuckles actually aren't rolled over all the way. They only require 1 stroke to form, and you can form 3 or more knuckles at a given time. They're great in the fact that they allow for a larger pin diameter, and they're much more efficient. Only 1 tool is required. With the 3 hits required in the closed style, the efficiency of an open style results in 89% cost savings over the multi-hit method. Again, 1 tool required, 1 hit required. Some examples of connective forms made with tooling that you may already have in your shop. These are really relevant to bent parts where you have some force from the flange that allows them to push out, but some of these examples are extrusions. A simple extrusion is placed into a punched hole to hold sheets together. You can use a half shear form placed into a punched hole, a simple louver placed into a rectangle punched hole, or a clip with rib, which is a basic shovel lance form, and then it's slid into and down on a rectangular punched hole. Again, just trying to get you guys thinking about some of the different things you can do with sheet metal and with tooling that you may already have in the shop. Talked a little bit earlier about the wheel tools and the requirements for having a programmable ram in order to hold the tool down. Moving on to minimizing secondary press brake operations, there are options using rolling tools, or you can make your forms progressively in your non-programmable ram machine. So the first illustration you see there is a progressive 90 edge form. You can do that with a rolling flare, or you can do it progressively with multiple hits. The great thing about the wheel tools and progressive hitting is that it allows you to achieve longer forms in your machine via progressive hits or rolling wheel tools. You know, that it eliminates the need for expensive press brake tools and reduces cycle time for smaller batch quantities. Often you have to move these parts to the press brake simply due to the length. Now, with progressive tooling and wheel tools, you can keep those in your punch press. One tool can produce forms of any length within your sheet parameters, as discussed. And then one I want to point out in particular is the dash tool. There is a progressive dash tool, also known as there's a rolling version known as the rolling pincher. What this tool does, it actually scores the material. And what that does is it allows for you a sharper bend radius that you may not be able to achieve with a press brake alone. So if you score that first, take it to the press brake, you can get a tighter bend radius. Or it also allows for hand bending in thinner materials, so you don't have to send it to the press brake. Moving on to the OptiBend tool. The OptiBend tool is a great way to eliminate the press brake in small flanges. It allows you to achieve bends up to 90 degrees in your punch press. And how it works is it uses a rotating cam in the die that bends the material during the punching stroke. The OptiBend works by simulating the cycle of a press brake. However, it's great in the fact that there's little or no part marking on your sheet. The OptiBend is available in a single hit function, and it is also available in a progressive style. I'm going to show you a quick video of the OptiBend tool to wrap up. What you saw in the video was the perimeter of the part being punched in the sheet, and then the flange being formed up to 90 degrees. Again, as I stated earlier, you are limited to the flange height to whatever the feed clearance of your particular machine is. The machines do vary in their feed clearances and range anywhere from a ½ inch all the way up to 3½ inches in some machines. Here's some illustrations of some forms made with an OptiBend. On the left side, you see single hit OptiBend, and on the left side picture, but the part on the right side actually shows that there is some overbend allowed by the OptiBend tool. The picture on the right side of the screen, it was made with a progressive OptiBend tool, which would allow you to do longer forms in your punch press. So to wrap it up, we discussed maximizing your tool life by ensuring proper grinding practices, applying surface enhancing coating, and then utilizing premium tool steels. We showed you how to streamline some of your applications and maximize machine capabilities through the use of efficient tooling technologies. And finally, we talked about eliminating secondary press brake operations and reducing the capacity on your press brakes by moving it to the punch press. We're going to move along to the question and answer session now.
From here. Like you mentioned, we're going to do some Q&A. We're going to take some time to answer your questions you sent in throughout the presentation. We just have a couple in so far. So if you have a question that you haven't sent in yet, please do so now and continue to send them in as we're answering your questions here. Okay, so the first one that came in is, does Wilson Tool sell grinders?
Yes, we do. Wilson Tool has two offerings of grinder. We have a large auto feed grinder, and then we also have a smaller version at a different price point that is manual feed.
Okay. The second one here is powdered tool steel an option for all tooling?
Powdered tool steel is an option for most tooling. In some instances, it does carry an upcharge. Glenn, do you know if it is available for all tooling now?
I would say it's available for all of our tooling styles.
Okay. what you have to be careful with powdered tool steel, we use a general powdered tool steel that is proprietary to Wilson Tool. It's a good all-around powdered tool steel called Ultima. There are some very application-specific powdered tool steels that can be used available as well. Very shock-resistant.
Okay, Joe, we've got another question here that has come in. It says, how do you measure the radius of a dull tool to tell if it is less than or more than 4 thou?
That's a great question, and I don't have a great answer for you. The best I can tell you on that, honestly, is the eye test. You know, it's very difficult to measure a 4 thou.
That's a good answer, Joe. A lot of people just kind of take your fingernail or your thumbnail and try to scrape it on the tool, and when you can't, you know, kind of scrape your fingernail on that tool anymore, you've got enough radius there that you probably should sharpen it. And it's just something that you kind of get a feel for after a while, what it looks like when a punch has a 4 thou radius on it.
Sure.
Okay. You know what? I think, you know, it's all the questions that have actually come in here. I know sometimes people don't want to ask them in this setting, but if you have one that comes in afterwards. Oh, you know what? We got one more that came in. We'll answer here quick before we end it. How much extra grind life do coatings add?
Coatings don't add extra grind life. They actually add extra hits by reducing the wear on the tool themselves. It varies by application. There are really too many variables to give you a hard number. I've heard it ranges anywhere from up to 3 to 7 times, but it will be specific to your application.
Okay. Joe, I'm not sure. Okay, and looks like another one came in here as you're answering that one. It says, is the tapping tool available for the Amada?
Yes, it is. The DK tapping tool is a thick turret tool. As long as that Amada is a thick turret style Amada machine.
So it sounds like maybe the audio is cut out on Joe there.
Can you not hear me?
You know, you're cutting out a little bit on our end. Not sure if it's us or if anyone else is experiencing that, but maybe Glenn can try and pipe in here to answer that last question.
I think what you were saying, Joe, is that it's available for the Amada. There are a couple of different versions of it depending on which tap sizes you want to run. It fits in either the 2-inch or the 3.5-inch station.
Okay, great. You know what? I think we'll end that there today. And like I said, if you have more questions, feel free to send them in to us afterwards. We'll get back to you on a individual basis. But first, I want to do a big thank you to our presenter, Joe, and thank you to all of you guys for joining us today. And like I said, for those of you who do have questions that were not answered or for more information on the ideas presented in this webinar, please contact your Wilson Tool sales engineer, or you can visit us at wilsontool.com.